simplify the complex fraction. It's called a complex fraction because it has nested fractions inside a fraction. So here is the big fraction bar, and there's a numerator and a denominator. And when the numerator has fractions in it itself, or the denominator has fractions in it, then it's called a complex fraction. And the strategy is multiply the numerator and denominator of the big fraction by the LCD of all the nested inside fractions. So we have to factor all the denominators of all these fractions. So the only one in this problem, the only ones that needs to be done is this one. So that happens to factor as x minus 3 times x minus 2. The other fractions are already factored, so that's good. If this one didn't have the 3 factored out already, we'd have to factor out the 3. So if it was 3x minus 6, we'd factor out the 3 to get this. So everything is factored. Then we build up the LCD. You need a 3. That's that. You need an x minus 3. That covers this one and this one. But we also need an x minus 2 to cover those two. So now every denominator is covered with this LCD. So now we're going to multiply numerator and denominator by that LCD. So we can make it nice by multiplying by a big giant 1. This is 1 in the form of the LCD over the LCD. That way it multiplies on the numerator and on the denominator. And we're not changing the value. Okay, so now you distribute over. This whole quantity has to hit on this one. And when it does, the x minus 3 and x minus 2 are going to cancel out, and you're going to get 3 times 1, which is 3. Then this whole thing has to hit onto the 1 over x minus 3. And when it does, the x minus 3 is going to cancel out with this x minus 3, and you're going to be left with 3 times x minus 2 times 1. 3 times x minus 2. That's that one. Now we're going to take the bottom and distribute that over the same way. When this hits over on this fraction, you're going to have the 2x already there. The x minus 2 is going to cancel out, and the 3 is going to cancel out. So all you have is the x minus 3 left. So there's the x minus 3. Then you're going to hit it onto this fraction. And when you do that, you can see that the x minus 3 is going to cancel out here and here. And all that's going to be left is a 1 times 3 times x minus 2. 1 times 3 times x minus 2. And it was a subtraction, so we bring that there. And we remind ourselves that the restrictions. This fraction was only 1, equal to 1, because x cannot be 3 or x cannot be 2. If x is 3 or x equals 2, this is an undefined number that we're multiplying by. So we cannot allow that. So those are restrictions. Then we clean up this, do some algebra here, clean this up, distribute the 3 in, add it together, you get this. Be very careful about this, negative 3x plus 6. That's very important. Distribute this out, you get this whole denominator there, and then simplify this down as 3x minus 3 over 2x squared minus 9x plus 6, and with the restrictions that x is not allowed to be 3 and x is not allowed to be 2. Again, the reason why you put those restrictions is that, see, you have a chain of equal signs. Here, 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 here. But there's something wrong there because I have to get rid of this thing here. So all these equal signs come all the way down to here, but the original fraction is undefined at every x that makes these denominators 0, which is everything that makes this LCD 0, which is x equals 2 and x equals -3. And in the new fraction, your x could end up being those and still being defined. So how can something that's undefined at numbers be equal to something that is defined? So that's why you need these restrictions, because they're only equal here. All these equals are only equal if you don't have these two possibilities for x.